So today's our last day with quadrilaterals. On Monday, we are going to review. Review for what you ask, review for the test that is on Tuesday. You have a test covering angles, triangles, quadrilaterals. So all of Unit 1 will be tested on Tuesday. Everybody with me? I'm also going to give you a project today. We're going to talk about it. It will be due on Wednesday of next week, so the day after your test. Yes? Okay. So we've got 2 more words for quadrilaterals. We've already started this flow chart. Parallelogram, rectangle, rhombus, square. There's a lot more stuff that we need to put on there, but I don't want to clutter it up yet. We're going to learn 2 more today. First one is going to be a kite. This is probably the only one that you really haven't seen before. The other one is a trapezoid. Okay, so that takes care of our flow chart. Are we going to keep on adding? Absolutely. So, let's review a little bit with the word adjacent. What basic definition did we have of the word adjacent? We talked about adjacent with angles. So what do we mean when we say adjacent? Come on, folks. If you don't know, go back in Unit... Owen.
Side by side.
Side by side. Not a bad one. Can somebody give me something a little bit different? Go ahead, Leighton.
Exact opposite.
Not opposite. We're not going to do opposite.
I am adjacent to CC.
But Mrs. Armstrong is not adjacent to Connor. Taylor.
Right next to.
Right next to. Very good. Adjacent means right next to. So 2 more words for Unit 1, and then it's time for a test. So we are in Unit 1, Geometry. Day, I don't know anymore, so we're going to call it day infinity. Like I have lost what day it is.
Yeah,
It's day infinity. I got screwed up last night. I mean, it's fine. We are in quadrilaterals.
It's day 11.
Day 11, not infinity. Day 11. Okay. We are in quadrilaterals, part 4. Bless you. Oh. So we are in quadrilaterals, part 4. 2 words and only 2 words left. So let's start with a kite. Yesterday, based off of our flow chart, we said a rectangle is a parallelogram. A rhombus is a parallelogram. A square is a rectangle, is a rhombus. So let's look at our flow chart right now. Will a kite ever be a parallelogram? Just look at the flow chart. Is there an arrow going from kite anywhere towards parallelogram? A kite will never be a parallelogram, which means our opposite side is going to be parallel? No. Our opposite angle is going to be congruent? No. Our opposite side is going to be congruent? No. A kite is never a parallelogram. So what is it? It is a quadrilateral. We know 2 things about quadrilaterals. A quadrilateral is a 4-sided polygon, and it has 4 angles that have a sum of what, Trevor? What's this? Very good, 360 degrees. Okay, so a kite is a quadrilateral with 2 pairs of adjacent congruent sides. And adjacent, we said meant what? What did we say adjacent meant? Right next to, side by side, right next to. Okay? So it's a quadrilateral with two pairs of adjacent congruent sides. Ooh. Now, we could talk about the angles, we don't need to. We're doing the basics of geometry. So here's our kite. To show adjacent. Adjacent sides are next to. So these are congruent. There's one pair, which means the other pair has to be congruent. They will never all be the same. If they're all the same, what kind of shape is that? Very good, a rhombus. A rhombus has four congruent sides, but it's a parallelogram. Will a kite ever be a parallelogram?
No.
No. Okay, so that's one way to see it. Let's look at the angles. Could we have two acute angles and two obtuse in a kite? Are these acute? Sure. Could these be obtuse? Absolutely. Are the angles ever all going to be the same? No. In a kite, you will always have two acute and two obtuse angles. Okay, I'm going to say that again. In a kite, you will have two acute and two obtuse angles. So how else could I show a kite? Well, don't be sorry, you're all right. You just shouting out, it's fine. So, if this is 7 inches and this is 3 inches, A, B, C, D. Be specific. Emma, what else has to be 7 inches? Be specific. Segment CB must be 7 inches. Adjacent, next to each other. How do I know they're next to? Because they're sharing vertex B. Renee, what has to be 3 inches? Oh, what do I call that? What? Not opposite. Emma, help her out. What was CB? What did you say that was? Segment CB. So what is this right here? Segment what? Segment DC. Very good. Those are kites. So on my flow chart, two pairs of adjacent congruent sides. Okay? Now, I'm going to put one other thing here. I'm just going to put over here, never a what? What do you think I'm going to put? Never a what?
Or not.
Raise your hands. Never a what? Luke? Parallelogram. Very good. That means the angles will never be 90 degrees. The angles will never all be congruent. The sides won't ever all be congruent. The sides won't be parallel. None of that holds true. Everybody with me? Last but not least. A trapezoid. Here we go. Is a quadrilateral. Will my trapezoid ever, ever, ever be a parallelogram? Will my trapezoid ever be a parallelogram? No. Will my trapezoid ever be a kite? No. My trapezoid is only ever a trapezoid because it's a quadrilateral. That's it. Okay? So it is a quadrilateral, and here's the key. with exactly one pair of parallel sides. So a parallelogram, both pairs of opposite sides had to be parallel. In a trapezoid, only one pair of parallel sides. So how are we going to see a trapezoid? Well, you might see a trapezoid like this. How am I going to show that it's a trapezoid? Well, we have to have those arrowheads on them. That is a trapezoid. That is a trapezoid.
Think in your head right now when you look at the picture of the trapezoid up there, why aren't the opposite, both opposite sides parallel? Think in your head, why are just two, one pair of sides parallel? Why isn't the other pair of sides parallel?
Talk it over with the person around you.
Yeah. Why isn't that the case? What would you say that in the math language? You got this one. What word would you use? They wouldn't have All right, so why aren't the other pair of sides parallel? See if you can use like really good geometric math language to describe that. What would happen? Who can explain that? Carly?
Because if they're raised on Friday, they would be in the middle.
Okay, if they were raised, they would meet in the middle. Yeah,
Okay.
that's true.
What is it called when two lines meet? What is that term that we use? Luke? Vertex? Well, they would eventually have a vertex, but what is when they create a vertex, what are the lines doing with each other?
Let's go this way. What happens when two streets cross?
Oh.
Trevor, what are they?
They're, whenever they cross is an intersection.
Ah.
So what do? They intersect. Okay. What's another reason these lines aren't parallel? There's one other reason. We look at our definition of parallel lines. What do you think, Owen?
They don't got them good arrowheads on them.
They do not have the arrowheads on them. Why don't they have the arrowheads on them?
They're not parallel.
They aren't parallel, but what's one of our definitions of parallel lines? They have to be exactly
Aligned with each other,
the same distance.
apart.
Right. Okay. Are those two outside lines? No. Okay.
Okay. So one more thing that we need to know. If a trapezoid is a quadrilateral, what do all of the angles have to add up to? 360. If I showed you this figure and told you this is a trapezoid and said this angle is 90 degrees, this angle is 30 degrees. What do you think this angle down here has to be? Owen?
90.
90. So, take a look here. Watch what I'm going to do. See my parallel sides? I'm going to draw a little dashed line between my parallel sides. Each half has to add up to 180 degrees. So if this is 90, Owen told me this is 90. Can we figure out how to find this one? What are you going to do?
Subtract 30 from 180.
Very good.
150.
So I would do 180 minus 30, and that would give me 150 degrees. Let's do another one. I want to find x degrees. See if you can try. Just what we did. I know it wasn't a lot. See if you can find it. Talk it over with the person next to you. See if we can find what x degrees is going to be. No, I just looked. Because you do. I understand that. That's why I'm doing it. It doesn't. Oh, here it goes. Okay. Okay, I'm sorry. Then I'm looking at this one. Okay. Then we're good. Well, no, because it doesn't have this one. I understand that, but it doesn't show that. That's fine. I mean, it's the same type of thing. You should know that. Owen, put it away, buddy. Okay. Luke, I don't need your help. So, Izzy, what does this angle have to be? Right here. 90 degrees. So I've got two ways that I can do this. I can say, here's my parallel line, here's my parallel line. I like drawing that dashed line and saying each side has to equal to 180. I can say, what am I, actually, I don't want to say. How can I find x? What can I do on this side, Luke? 180 minus 100, and that gives me 80 degrees. That's one way. That's how I prefer to do it. What else could I do? I could say 90 plus 90 plus 100 plus x equals 360. Could I do that? So this is 180 plus 100 is 280 plus x is 360. I could subtract 280 from both sides. That gives me x equals 80 degrees. Either way works fine. The key though is knowing if one angle is 90 degrees, what does that angle on the other parallel line have to be? 90 degrees. Questions here? I must just put that cap in my coffee. Okay. Mrs. Armstrong, because your handwriting is so much nicer than mine, would you mind coming up here? Would you mind? Hugely. I mean, you can say yes.
I would mind.
I mean, it's fine if you mind. I'm still going to ask you to do it. So, we are not giving you anything. Right now, there is one thing. Right now, there is one thing, two things, I guess, on Kite. That's the only one we're giving you. Get your flow charts out. You're going to tell us what is important about each figure. So, we're going to start with quadrilateral. Once you have it, I expect every single person to be able to raise their hand and give us something, because you all have these flow charts.
Taylor K. And tell us where.
Quadrilateral.
Okay, so what's one piece of information we need to put at quadrilateral?
4 sides.
Can you be more specific? It's a four-sided what?
Polygon.
Very good. Four-sided polygon. Excellent. That was horrible.
Okay, four-sided polygon. What else? What else, Layton?
Quadrilateral again.
Okay.
360 degrees it must add up to.
What has to add up to 360 degrees?
Quadrilateral. The angles, all the angles.
Angles. There you go. Can we use, you said add up to, what's another way to say that?
The sum.
That have a sum, okay. And again, we talked earlier, if you don't have this information for some reason, let's get it down. Okay, Taylor A.
Parallelogram.
Okay, what about parallelograms? Okay, opposite angles are congruent.
Good. And if you don't have this flow chart, make sure you're adding to it.
All right, what else?
On parallelogram, opposite sides are congruent.
So opposite sides are congruent? Whoops. All right, anything else? Ryan?
Parallelogram, opposite angles are congruent.
Look at that, our parallelogram has all sorts of stuff. Oh, we have opposite angles are congruent. Can you think of something else? So we have opposite angles are congruent, opposite sides are congruent. Think about,
What's the name of it? Oh, what? Parallelogram? Okay.
so what is that?
Parallel.
So what's parallel?
Angle.
Well, one of those. Which one?
Angle.
So opposite sides are parallel. Whoops. Made the wrong parallel symbol. Okay, opposite sides are parallel. Okay, Luke.
Rectangle,
What about a rectangle?
4 right angles.
Okay, rectangle has 4 right angles.
Is there another way that we could say that instead of 4 right angles? What could they also be?
What else could they be, Emma? Okay.
Congruent
It can be congruent.
angels.
Well, angels are angles.
Oh.
You know what? I did say angels. Thank you for correcting that. Because we don't want to know that angels have a sum of 360 degrees. We want to know that angles have a sum of 360 degrees. Okay, we've not talked about angels so far in here. It's not a geometric term. All right, what's next? Who else? Who else? Who else? Come on.
Come on, guys, you got your flow chart in front of you.
Layton.
Can I do, wrongness?
I don't know. Can you?
Sure.
Okay, go for it.
It must have 4 congruent sides.
Okay, 4 congruent sides. Oh, Carly.
Square must have congruent angles and 4 congruent sides.
Oh, and Carly gave us the and, okay, with a square. It must have 4 congruent angles and 4 congruent sides.
Love it.
Nicely done. Okay, we have
One
one
more
more,
thing.
one more shape, one more polygon. Trevor.
It's square, correct?
Well, we have information for our square. What one are we missing here?
Trapezoid.
Okay, Trevor, go ahead. Trapezoid, what do we know about a trapezoid?
It is a quadrilateral with exactly 1 pair of parallel sides.
Okay.
Exactly 1 pair. Not 2 pairs. Exactly 1. So if it had 2 pairs, then it's a parallelogram.
Parallel sides. Okay.
So,
You gotta
Go ahead.
write always on all the arrows.
Oh, you know what, Owen? Thank you. Say that again, because I don't know that everybody heard you.
You gotta write always on all the time, or on the anything.
So, on our arrows going upward, starting at square and going up towards parallelogram and to quadrilateral, we have to write the word always. Thank you. Which doesn't mean sometimes, it means always. Again,
Bless
if you
you.
don't have this information down, get it down on your flow chart.
once you're sure that you have that copied down, you're going to want to make sure that you get out another piece of paper. you're going to want to take a look at the whiteboard because we're going to go over your project that is due next Wednesday, which is the day after the test. Okay, for this project, it is a quadrilateral drawing. I'm going to give you a demonstration of what I expect, but here are the must-haves. So you know this symbol is greater than. What does that line mean underneath it?
Or exactly.
Or equal to. So it can have 2 or more parallelograms, but it must have at least 2. At least 2 rectangles, at least 2 rhombus, at least 2 squares, at least 2 kites, at least 2 trapezoids. So you're going to have at least 2, 4, 6, 8, 10, 12 quadrilaterals on a picture you're going to draw. Everybody with me? Then it must show Y. Do you only have to use quadrilaterals? No. You can use circles, you can use an octagon, you can use straight lines. You are going to draw a picture. The more creative you are, the better. Am I going to knock you for creativity? Absolutely not. I am by far the worst drawer that you will ever see. That is plain and simple. I am by far the worst drawer that you ever see. Would I love it if you colored it so I can hang these up? Sure. But if you give me something in pencil that's done correctly, I'll be fine. Right, Rebecca? Okay, stay with me, honey. So, what do I mean? Well, I'm going to draw a figure. A really, really bad figure. Oh, man. Already off to a bad start. Already off to a bad start. I should have just kept with my house. But no, I'm trying to... What am I doing here? What am I doing? Hold on. I'm trying to draw a trapezoid. Stop it. There we go. Yeah. So there's one trapezoid. That's showing Y. That is a trapezoid. Does everybody agree? Then I might draw another trapezoid. What makes these trapezoids? What makes them trapezoids?
That are at, well, parallel sides.
How many parallel sides does a trapezoid have to have?
2.
Exactly 1 pair of parallel sides. You cannot use my example, just so you know. You don't have to draw this down, but you can't use my example. Then I might have this. What did I just draw now? 2 rectangles, right? I drew 2 rectangles. Everybody agree with that? Okay. This is where I'm going to start struggling because I'm not a good drawer. I'm not. What did I just draw there? A square. Does everybody agree with that? It's going to be a robot, yeah.
It looks like SpongeBob.
Everybody still with me? AI. Sit up, honey. We good still? So, what would I keep doing? I would keep drawing all of these. Like maybe he's going to have buttons. I don't know. They are in my head. So there's my kites. Still with me? Then I might have another square here. I don't know, guys. Oh, look, now it's a nose. This is a funny little guy. He's a funny little guy.
Those little squares look like
Okay. Still with me, yes? What am I missing? So I've done 2 rectangles. I've done 2 rectangles. I already did 2 rectangles. 2 trapezoids, 2 kites, 2 squares. Now I need rhombi. Everybody with me? How am I going to show it? Okay, so now I've got my rhombi. What am I missing? I'm missing parallelograms. Okay. Sure. Now watch what I'm doing though. Actually, no. I don't want that. Stop it, Mr. H. Stop it, Mr. H. Did I draw? Are those parallelograms?
Yeah.
No. Well, they are a parallelogram, but that's not the most specific name. That's still a rectangle, right? Oh, we've already done rhombus. So now I need to draw my parallelogram. How am I going to show it? Okay. Yay! Now, I mean, it's a shape. Do I want you to color it? Yes, but what do I need to see? Because the must show why. I need to see all of what's making it a parallelogram. I need to see the parallel arrowheads. What makes it a kite? I need to see the adjacent sides are congruent. Everybody with me? Now, what did I do that you should not? I did not use what's called a straight edge. Okay? Everybody with me? Do not turn in something that you have drawn by hand that is like 3 minutes before class. Everybody with me? On your own paper, I would practice it. I would absolutely put it on your own paper. Okay, I'm going to come up here. So here's our stuff that has to happen. Here's me showing it's a trapezoid, it's a rectangle, it's a square, they're kites. You need to have all of this. Here's how the grading's going to work. For my 2 parallelograms, 2 points, 4 points, 6 points, 8 points, 10 points, 12 points. The showing why is 8 more points. This is a 20-point project that is due when?
Wednesday.
Next Wednesday. Izzy?
Can we use more of the shapes?
Yes. So, these greater than or equal to, how many rectangles did I use? Well, I used 1, 2, 3, 4. Okay, you can always use more. Everybody with me?